Hi, this video will help you review all of the major concepts on the Pre-Algebra Advanced Unit 5 Formative 1. First, you need to know the difference between complementary angles and supplementary angles. Complementary angles are two angles that add up to 90 degrees, and supplementary angles are two angles that add up to 180 degrees. There are a couple ways to remember the difference between these. The first one is thinking of it alphabetically. Complementary comes before supplementary, therefore it's a less than. Supplementary, or S, comes after C, so therefore it would be bigger. Or you can remember that if you start with a C, you can turn that into a 9. Or if you have an S for supplementary, you could add that, or you could add to it and make an 8 for 180. So you would have a C that turns into a 9 for 90, and then an S that turns into an 8 for 180.
Why do you have to make those?
Take a look at these 4 angle relationships that will help you find and prove angle measures. All of these highlighted angle relationships mean that they have equivalent or congruent angle measures. The first one is corresponding angles, and corresponding means that they sit in the same position. This is an example of corresponding angles right there. The second one to the right is alternate interior angles. Alternate interior angles are two angles on the inside of two parallel lines, and they are opposite of the transversal. Next we have vertical angles. Vertical angles are two angles that sit across from each other when two lines intersect. And then we have alternate exterior angles. Those are two angles on the outside, or the exterior, of two parallel lines cut by a transversal. Again, remember that all of these have two angles with congruent measures. These angle relationships prove very helpful when determining angle measures when only given a small amount of information. For example, if they give you that the measure of angle 1 is 70 degrees, you can figure out every single angle on this image. To start, angle 2. I can see that angle 2 is adjacent to angle 1. Also, when you put those together, they create a straight line, which is supplementary angles. So I know that the measure of angle 2 is 110 degrees because angle 1 and angle 2 are supplementary. I'm going to abbreviate that for you. Then I could look at angle 3, and I can see that angle 3 is across from angle 1, which makes them vertical, and vertical angles are equivalent. So I know that angle 3 is 70 degrees because angle 1 and angle 3 are vertical. Then I can look at angle number 5, and I can see that that sits in the same position, which makes it a corresponding angle. And corresponding angles have the same measure. So angle 5 is also 70 degrees because angle 1 and angle 5 are corresponding. You could also at that point say that angle 3 and angle 5 are alternate interior angles, which also have the same measure. Either one of those justifications will work. You can continue to do that for the rest of the angles on this figure. Angle 11, if you look at that in comparison to angle 5, you can see that that also sits in the same position. So you could say that angle 1 and angle 11 are corresponding, or you could say that angle 11 and angle 5 are corresponding, which in turn gives them congruent measures. So angle 11 is also 70 degrees. From there, you could say that angle 12 and angle 11 are supplementary because they add up to make 180. Therefore, 112 is 110 degrees. And then you could jump to angle 16, which you could say is alternate exterior to angle 3. You could say that it's corresponding to angle 1. You could say that it is corresponding to angle 11. You can use any of those justifications as long as they are accurate. You will be expected to classify the different types of triangles. You will also be expected to be able to draw them. Take note of how you prove how many equivalent sides you have by using those indicators on the sides. And also notice the angles. If they ask you for a scalene right triangle, that would mean that you would need to draw an angle with all different sides, with one angle measure being 90. And for example, you could draw a triangle that looks like this. It would be scalene, so all sides would be different. And you show that by not having any of the same number of marks on those sides. And then you would also want to show in there that one of your angles is a right angle. Also remember what it means to be a regular polygon. A regular polygon is a polygon with all equivalent sides and all equivalent angles. So the one regular polygon that is a triangle is your equilateral triangle. All your sides are the same and all of your angles are the same. This is kind of like a puzzle, and these are fun. Try to remember all of the different rules that you know, and then you can solve for all of these different angle measures that are missing. The first one that I am going to start with is one that jumps out at me up here. Angle A is across from, or it's a vertical angle from 60. So I know that angle A is 60 degrees. Now, if I look down here, I can see that I have three angles here that add up to be 180. I'm missing this piece right here, but I know that the other two are 110 and 51, which is 161. So in order to add up to be 180, I know that angle B has to be 19 degrees. Now, angle A, B, and C inside of that triangle I know have to add up to be 180. So if I have 79 degrees, in order to add up to be the total of 180, which is the interior angles of every single triangle, again, 60 plus 19 is 79. So I would know that angle C has to be 101 degrees. Now, since angle C is 101, I know that together with angle D, that is also supplementary because it creates a straight line. So I know that angle D is 79 degrees. Now, to find angle E, I have two of those angles in a triangle, so now I can find the third. If I take 79 and add that to 51, that gives me a total of 130. So therefore, in order for this to add up to be 180, angle E has to be 50 degrees. Find a place to start and keep working using all of your angle relationships and rules until you can find all of those missing angles. And as always, good luck.